All right. Questions? How's PA2?
Yes. Can we go over like the algorithm for like the word use?
Yeah. For inserting or the whole thing?
Just the way you wrote it.
So this will work better if I actually have. Yes, I do have the assignment with me. So your word list. Right, is a class. It has something that represents the root or the handle to your linked list. Right, it might be the first node or null, it might be the actual sentinel node if you have a sentinel, but it's something that you use to refer to the list, and I think I've just been calling this the list. I've called it root before. And the list assuming you've already got some stuff in here, is a linked list of W nodes. So here's ant, here's bat, here's dog. So three words in our collection. And your input was and bat and dog and cat. All right, so your main program is constructing an index utility. An index utility has one method that you really care about, which is build index. And that scans standard in, adds words to the word list, and then returns that word list. So you've read the first 5 words, that's what your structure is going to look like, right? This is a data structure here sitting inside word list, okay? It is collectively called a word list, right? But the word list contains a W node, which is, in this case, this node right here, and which points to all these other nodes, okay? So when we talk about a word list or returning a word list, we're talking about this collection of data, right? But that's really one piece of what a word list actually is. Okay, so that's one point of potential confusion. So you're in your build index method, and you scan standard in, you see the word cat, and you increment your position from 5 to 6. And to add the word to word list, you would do something like the list add I mean, you wouldn't put this in quotes, but you know, you got some variable that you scanned your word into. That's the variable name you put there. That's whatever variable is keeping track of your position. But effectively, you're calling the add method of this word list, adding the word cat to position 6. All right, so how does that algorithm, how does this add method, maybe I called it add word.
Yeah,
Add word, okay. So add word is inside this word list class, which means the code in add word has access to this variable, this object called the list, right? So you look at the list. If the list is null, you've got nothing in your list yet. So that's an edge case. But in general, right, you might do something like temp equals the list. And then while temp is not null. And this won't work exactly, but pseudocode-ish. So if temp data is bigger than, so let's just say this is word and position. If temp data is bigger than word, right, so we're inserting cat, so when we look at and comes before cat, okay, so we don't want to insert before and. Bat comes before cat, so we don't want to insert before there, but eventually temp's going to be this node here, and we're going to say dog is after cat, right? So we want to insert before this node. So if temp,
so this does like alphabetical rearranging.
so this is alphabetizing them, yeah, or keeping them in alphabetical order, right? So this is a compare to,
Or whatever it gives us.
yeah. So if you found a node that's bigger than the one that you're inserting, insert new node before temp. Okay, and then set up the new node's position list and return. And that's probably going to be the most common behavior. You walk through and you walk through and you eventually get to a node and you realize you're supposed to insert right before there. Okay, so you create a new word list node, you stick your word into the data portion, you sandwich it in between this node and the node that came before it, and then you initialize its position list, right, this piece down here, to be a linked list containing one node, which in this case has the number 6. Okay, how do you sandwich before the dog node? As you're going through, right, you do a pair of pointers is one way to do this. So we have previous and temp. And we check temp, and bat comes before cat. So we set temp to temp next. And we set previous to previous next. And now we compare temp's data with cat, and it comes after, so we want to insert between previous and temp, right? And you've done this before, so your new node's next equals previous next, and then previous next equals your new node, and that sticks it in between. Setting up the new node's position list, that's something that your position list class can handle for you, right? So in your position list, you have methods for constructing, and you can be guaranteed that every time you create a position list, you have at least one node you want to put in there. Because I'm not just creating position lists out of thin air, I'm creating a position list because I've got a new node and I want to put a 6 in there. So you can make the constructor of a position list accept an integer if you want, and it just creates a single node with that integer value next equal to null, right? And so when you construct your word node, you take your third field, position or whatever, and you just set that equal to the new position list, whatever position you're using. So that's the case of inserting a new word. When you're going through here, if you find that the temp node's data is equal to your word, so comparator returns a 0, then you don't need to add that word to the word list. It's already there. You just need to add another node down here with the new position. And that's just something like temp dot position list dot add in whatever position you want to add it to. And this is this linked list of integers. And that class of linked list of integers comes with an add method that will march through the stuff you were doing yesterday. It will march through, find the last node, stick it equal to a new node. Or if the position list was empty, right? But the position list won't ever be empty if you do it like this.
And you can always stick it right at the end because you're never going to have a number smaller than what's already
Right, and that will keep those numbers in increasing order because every time that you call this, position has been increased in your build index method. So the words you have to do some work to alphabetize. The positions, if you just put it on the end, it's always going to be in increasing order. Does that make more sense? Okay. All right, other questions? Well, let's talk about PA3 so we don't forget. So this is up on Canvas now. It's a one-page assignment. Should be easier than the four-pager, right? So I'm going to have you do a tic-tac-toe game. Okay, this is going to be graphical. So you're going to basically paint a tic. Does everybody know how to play tic-tac-toe? Okay.
Maybe.
Let me know if not. You're going to paint a tic-tac-toe board on your screen, and you're going to have various options. Who gets to go first, you or the machine? Do you want to be X or O? So the user gets to choose. I think those are the only mandatory options.
Are you making different difficulties?
Say what?
Are you making different difficulties?
Yeah, so you're going to have a lot of flexibility in where you take this, and that's one flex point is you can have an AI with like increasing, takes 100 years to make a move kind of thing. So suppose the user's going first. Okay, they take the mouse and they go anywhere in this region and they just click. And let's say they've chosen to be X, right? So they click here, you draw an X. And then the computer makes a move. And the computer says, okay, I'll go here. And then the user takes the mouse, clicks somewhere, makes a move. And you keep playing, so the computer makes a move here. If at some point somebody wins, right, then you detect that and you draw a winning line through the marks and the game is over. Okay, and there's like a restart button. And you can click that, it'll clear the field, and you can start playing again. All right, that's kind of the bare minimum. Okay, that's enough to get you full credit if you get that working correctly. But there's a lot of room to get creative and fancy here, right? So I will allow you to have the computer make random moves as long as they're legal moves. Okay, so it can't like take a square that the user just took or that it's already taken. It can't decline to move. But if you want to just pick a random square that's available, that's fine. Okay, but it's also fun to actually figure out how to make it harder to beat. And you can make it so it never loses, right? You can't necessarily make it so it always wins. And if the computer goes first, right, so there's some kind of start button or restart, and when you hit that, then the computer would put its mark in its first square, wait for you to click somewhere, and so on. All right, so details. I'd like you to do this in Swing, right, with Swing classes. I recommend using Window Builder, but if you want to do it barehanded, you can do that. That's fine. So a way to select who makes the first move, a way for the user to choose whether they're X or O, a start button, which also restarts after the game's ended. some sort of information window, which at least tells you when the game is over and tells you who won. If you have something where the computer might be sitting there a long time trying to make a move, you want to have some way to indicate that to the user. Like computer is making a move, or user's turn to move. In most cases, the computer's turn is going to be so quick it's going to effectively always be the user's turn. But if you're doing something different, right, make sure it's clear what's going on. Tic-Tac-Toe board drawn within the window, so this is all going to sit in a J-frame somewhere, right? Does not have to be resizable, but if you want to make it resizable, that's a good challenge too. Okay, otherwise pick a reasonable size that'll display on a typical device. Detecting mouse clicks inside the game board, responding to them. If you click outside the playing field, don't just pick a random square for the user, right? Do nothing or beep or put up a message or flash or something. So sanity checking the behavior of the system, right? A way to detect and indicate when somebody has won, and a way to restart a new game. Okay, so sanity checking, right? Can't make multiple moves in the same spot. The user can't decline to move, can't make 2 moves in a row by being really fast with the mouse and stuff like that. And make a zip file, export it from Eclipse, upload it. That's the whole description of the assignment, okay? But like I say, there's a lot of creativity that you can get to. But I'm going to insist that you do the drawing yourself, and we're going to talk about how to use the graphics class and the paint method and repaint to actually draw lines and X's and O's and things like that. What I don't want you to do is make 9 buttons, okay, so that the person clicks on a button and it picks that up. You can do that. It's a lot easier to do that, but you're going to miss a lot of the point of the exercise, so I'll definitely deduct for that. Okay, so it should just be a field that you're drawing in and you're picking up mouse events. And this is going to be event driven, right? You can't have a loop that says do this, do that, do this other thing, go back to the top and repeat, right? Because you don't do anything until once the game starts, if the user's going first, you don't do anything until the user clicks in a square, right? But when they do click in a square, that's when you're going to go into your action listener, right? Be told that a mouse event occurred. Here's the X and Y coordinates of the event. And now you got to decide what to do based on the state of the game. If the game hasn't started yet, don't do anything, you know, or say click the start button first. If it's the user's move and they clicked in an open square, draw the mark, switch to the computer's turn, and so on. Okay, so it's definitely going to be very stateful. All right, so questions about this?
If I make it so the game always stalemates, will I be deducted for not having my winning or losing screen, even if I do another one?
Make you really good.
Oh, so you're gonna have like
A perfect day.
just no code to handle the possibility that somebody won.
I mean, I can put it in there, but would you give me the benefit of the doubt that works?
I would go ahead and put it in there. I mean, it doesn't have to be much. If you have an information box, it can just be a set text entry, right? But if you want to comment it out and put a comment in there saying like this will never happen, that's okay. Okay.
If we make the AI super predictable, would you dock us for that?
No, doesn't have to have an AI at all. It can be totally random moves.
Well, I'm just thinking if you always try to do them in the same order every time, that's fine.
That's okay, yeah. But yeah, so I mean, you can just like take the one closest to the upper left or something like that. Yeah, that's fine. People are gonna laugh at your computer though. You're gonna say, play this game. It's like, really not very good at this. At least random, you can say like, there must be some deep strategy here.
I'm just thinking that would be the easiest thing to do.
That's pretty easy to do, yeah. It's actually a little easier than random, because random, you can pick a random number, but then you gotta make sure it's not occupied, and you don't wanna loop forever, and theoretically you could, unless you only randomize the open squares. So yeah, that's a little easier. or you can just always go to the right of where the user clicked last.
As long as that's
Should
not
be like
right, you're
really
right.
annoying. Adding an AI is not too hard though. Okay, so that can be fun. But I'd like you to try to have fun with the graphical parts of this too, right? It's an excuse to get into swing, right? You can make the whole thing black and white, but you can also use colors, right? It's pretty straightforward to do it. We're going to talk about different things that are available in the graphics class, different ways to draw shapes and control attributes and so on. So you've got lots of options available. But there's also, a fair amount of challenge just in getting the basic minimum working. So definitely make sure you get that going. But along the way, if you get bored, you want to play with color or whatever, that's fine.
Make some little text when you win.
Yeah.
Some just nice fireworks or something.
Yeah. You can throw in music in the background. I mean, you can.
Are you able to like set up a link that opens up like an internet browser window that takes you to the Rick Astley Never Gonna Give You Up?
Yeah.
And if you click off the
You could
off
do
the
that.
keyboard.
That would teach the user really quickly like, where the boundaries are. All right, and this is a fun one for me to grade usually, because I just sit there and play tic-tac-toe all weekend. All right, so we've got to talk about some things to make this doable. Probably the first order of business is really this question of doing graphics in a window, okay? Displaying lines and circles and stuff like that. And I gave you a really rushed intro yesterday talking about pixels and CRTs. And we don't need to get to a horribly fine-grained level, but just for a moment, think about this. Your display is effectively, it's a grid. 1900 by 1280 or whatever, depending on your equipment. And suppose you want to draw a line from here to here. So we've got XY coordinates, and usually 0, 0 is the upper left. So we move across, we move down, and whatever coordinate this is and whatever coordinate this is, we want to draw a line between those. And that's a question of choosing which pixels to light up to make this thing look like a line. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 pixels to move over, and 1, 2, 3, 4 pixels to move up. So roughly speaking, you want to go over 2 and up 1. Maybe something like that. But if you were drawing a very horizontal line, right, you might want to go over like this and then hop up halfway across. How do you code that? How do you write an algorithm to figure out which pixels to light up to give you a line?
Find the derivative.
Could find the derivative, right? So derivative for a line is what?
It's whatever
It's slope, right? So rise over run.
Yeah, that's true. You could have counter like the slope, rise over run, 2,
Yeah.
1, 2, 1.
Mm-hmm. And it gets tricky when these things are not integers, right?
Yeah.
Because everything here is going to be integer coordinates. But it's not too bad to do. Doing it efficiently is a little trickier. One of the old algorithms for doing this is something called the Bressenham scan conversion algorithm. I think it's still used in a lot of cases. And it's a pretty efficient way to figure this out. And you got edge cases, right? When you have a perfectly vertical line, the slope is infinite. But
But then you just light up
but
all
you
the
just
pixels
light
in
up all the
between
pixels,
vertically.
so edge cases like that. And then there's other details, like if you actually color this in, you get kind of a jagged line, And this one in particular, you get a big jump,
It looks
right?
like Microsoft Paint.
And it looks like Microsoft Paint, right? And so you start doing things like anti-aliasing, right? So you start lighting up pixels around here, and maybe you light them up in a slightly less intensity, so you basically blur the line, but it smooths it out when an eye is looking at it, right? So there's details like that. And you could go down to this lowest level and just light individual pixels and set the color of each pixel and do this yourself. Okay, we're not going to go down to that level. So we're using a class called graphics that has all of this kind of stuff built in. Okay, it will let us draw lines, it'll let us make circles and ovals, it'll let us do rectangles, it will do text, which is nice, because otherwise when you want to draw text, you've got to somewhere store the fact that an R looks like this. Right? And you gotta light up the pixels accordingly. So it'll do that for us. And it'll also fill in regions for us. And that's useful because if you have kind of an arbitrary polygon and you want to fill in the region inside, that's a whole nother algorithm. And there's interesting ways to do that. There's a really easy recursive way to do it.
Wouldn't it just be as you're painting the screen when you run into something, like anything on that shape, you turn on your fill, so it would go until it finds another part of that shape and then it turns off again?
Yeah, that should work. I'm wondering about,
But you'd have to make sure it's that shape.
yeah, and you gotta make sure what you're bumping into is part of that shape
Yeah.
and not part of another object. But you can also do it recursively. You can just fill in yourself and then recursively fill in the area right around you and stop when you hit a border. But we don't have to worry about those levels of detail, so we're going to work a couple of levels above that. So mostly you're going to work with graphics. And we have all these methods available to us. So starting with draw a line, so we can put in X and Y coordinates for the beginning and end of a line. We can draw a rectangle. We can draw a round rectangle where we round off the corners. We can fill a rectangle. So a rectangle, we give lower left corner and then height and width. We can fill in the inside. We can also fill an oval. We can draw an oval, and it just takes major and minor radii. So for a circle, we just set the width and height to be the same. We So yeah, there's kind of a whole notion of sort of the attributes that are set up. So we can set up colors, and then if we say draw a line, it'll draw it in that color, and if we say fill rectangle, it'll draw it in that color, and then we can set the color to something else, and what we draw after that will take on the new color.
So the draw oval for the X and Y, that's the center of the circle, right?
That would be nice.
Upper left corner.
Yeah.
Okay.
So that's a bit of a,
So I imagine it's probably drawing a square and then filling.
yeah. So it's not horrible to work with, but drawstring does text.
All of your regions are the same.
Yeah, and then there's these 3D ones that aren't as exciting as they should be, but they look 3D-ish. Yeah, so we'll talk about XORing pixels shortly. Let's talk about color. So color is another class, and the kind of old school view of color is we've got red, green, and blue. And that electron beam that's hitting the screen from yesterday, we can think of it as having an intensity. So minimal would be like 0 to 255, so an 8-bit intensity. And we've got 3 of those beams one that causes a red spot, one that causes a green spot, one that causes a blue spot. So 0 to 255, that's 8 bits. And 8 bits for each of these. So 24 bits of color information. And that lets us specify any mix of 256 levels of red, green, and blue, which gives us 16 million colors, theoretically. So if all of these are set to 0, that's black, no colors mixed in. If you peg one of these at 255 and set the others to 0, you've got just red, green, or blue. If you set them all at 255, you've got white. If you set them all at 128, you've got something halfway between black and white, that's gray. And you can just do levels of gray by keeping red, green, and blue the same and just changing what the setting is. Or you can do red and green and get yellow, and you can do other mixes like that. Red and blue gives you purple, and so on. And so a color we can construct by specifying red, green, and blue as floating point numbers from 0 to 1, or as 8-bit numbers in a single integer where it's packed together, or as 3 integers, red, green, and blue. Okay, lots of different ways to construct a color. But constructing a color doesn't do anything on your display, it just gives you an object that corresponds to that color. And there's actually a bunch of constants set up in here. Color.gray, color.green, color.cyan, right, which correspond to those particular colors.
What's the reason for having a lower and uppercase?
I do not know.
Just redirect you to the same thing.
So gray, gray, color gray in the default sRGB. So this one's newer, I guess. Usually, I think constants like this tend to be uppercased to make them stand out, and maybe that's the change, is they introduce the uppercase version. I don't know. Do you know? No clue. I'll go with the uppercase is more standard theory.
Colors have changed.
Colors have changed, yeah. Gray is the new gray.
I know in JS you can look at the uppercase, but lowercase isn't really defined in JS. So it could just be like a standard or something like that.
Yeah, yeah. Because they wouldn't want to break anything, so they would keep the old ones around.
And more compatibility, more options.
Yeah, yeah. And then there's other methods you can use on here, like brighter and darker and things like that, that will let you tweak your colors. Alpha is usually we just set alpha to 255. It's sort of how visible the color is, but we don't need to mess with it. But you can also do hue, saturation, brightness instead of red, green, blue. That's another way to specify color. As usual, you could spend like a few days just exploring this one class, right? But we don't need to. All right, so we can say set color and give it a color object, and that will basically arm this thing to use that color the next time that we do some drawing. Same thing with set font, right? So you can set a font, and then the next time that you try to paint a string, it'll use those font attributes. And there's different ways we can tell it what to do when it paints on top of something that's already painted on the screen. And this is where XORs are useful. So you have a blue line like this, and now we're going to draw a red line. And what should it do on this pixel right here? Should it just make it red, because that's the new line? And if it does, are we okay with the fact that we obliterated our blue pixel that was there? And if you get into something called video lookup table animation, there's reasons why you might actually want to combine these colors. and that's where an XOR is going to come in useful. And this is a little off topic, but it's cool enough that I want to mention it to you. Because it's one of those concepts that, at least when I was introduced to it, it became like the thing I did for the next 6 months. VLT animation. So this idea of a video lookup table, you have your screen. Can't quite see it. There we go.
Now we can see.
All right, thank you. So you have your screen, and we've said that these pixels have different colors associated with them, right? So where is that stored? It's stored in memory somewhere, right? On an inexpensive laptop, it steals part of your main RAM, and it says, I'm using this for my video memory. Okay, and a nice graphics card, it'll have its own memory. But somewhere there's information stored that basically, in the end, tells you what the color of each of these pixels is. And as your display is refreshing and lighting up pixels or darkening them, it's reading from memory to know what values to put in each pixel. Okay. Now we could store directly in memory red, red, green, purple, red, green, purple, black, and so on. But usually that's not what's done. Usually there's a level of indirection. We say something like this is color 1, 1, 2, 1, this is 4, this is 2, this is color 3, 3, 3. And we have a table somewhere that tells you what those colors are. So 1 is red, and 2 is yellow, and 3 is dark red, and 4 is white. And as it's refreshing your display, it knows that this should be color 2. It'll look in this lookup table and say color 2 is yellow, and it'll go ahead and set that pixel to be yellow. Wait, why do we want a table of indirection here instead of just storing the colors directly? Because it lets you do animation really easily. And here's what we can do. Suppose I have a picture displayed and it's drawn mostly in yellow. Right, so let's just make a yellow rectangle. If I come through and I just change this to black, my entire rectangle disappears immediately. I didn't have to go through and change all of these 2's to 0. I changed one entry in my color table and my rectangle disappeared. And now if I change it back to yellow, the whole rectangle appears again. So suppose I do this. Put another rectangle here in color 3, and color 2 is yellow, and color 3 is black. I see a rectangle up here. Now I change 2 entries in my lookup table, make this black, make this yellow. This rectangle disappears and appears down here, and it just moves down. So if you set this up right, you can do animations where you have some complex object and it moves around the screen or changes or things like that. And you do it without actually doing the intensive redrawing of this, which if you actually did that while it was visible, the user would see it and it would look goofy, right? So you effectively draw in this invisible color, and then you switch these 2 entries and say make that visible, make the old one invisible.
Is this how they did pixel animations?
That's how a lot of the early animation was done, yeah.
I feel like that kind of doesn't come up anymore because you know how one object has 100 colors now.
Yeah, yeah.
So when that move, you're going to have that another 100 table like this.
Well,
But you can do that still.
Yeah,
I mean,
you can still have a
you
lot of them.
use this chunk of table for the first object and this chunk for the second, and by basically just switching which one is active, you can make things appear and disappear. So this was like old school animation techniques, and it doesn't affect us. Like I say, it's kind of off topic, but it's a cool thing to know.
Could use that for fireworks.
Yeah, totally. I'm gonna get fireworks in your tic-tac-toe, aren't I? Awesomeness. All right, so we've got most of what we need so far, right? We know we can draw lines, we can set colors, things like that. There's also this graphics 2D class, which more people tend to use, because it also has other attributes like line width, meshing, things like that, stroke details that you can set up. So if you want to draw dashed lines and so on, you can do that. But everything we're going to describe works basically the same, whether we're using graphics or graphics 2D. But here's the one thing that's missing, right? To say something like fill a rectangle, sorry, I'm in color. To say something like fill rectangle, that's a method, and it's a method in this graphics class, which means we need to have a graphics object. And we could try to do something like this. But there's no reason to believe or expect that that's going to draw a rectangle on my display, just because I created a graphics object. There's got to be some way to sort of link this to something so that if I have, say, a J frame or a J panel, it'll actually do drawing on that. Okay, so we need to make that connection, and that's where it's going to get slightly weird. So let's write some code. So we'll call this draw stuff. And I'll put up a J frame as usual. And if I go to the design window and I look inside here, here's my J frame. Okay, under class it says J frame. But remember, there's also a content pane inside here. And the content pane is what we're actually going to draw on. That's called the J panel. We can draw on other things as well, but a J panel is a convenient one because it's already created for us. And a J panel is one of these things that's a component, a container, a component, and an object. But it has a method called paint. And paint is what you use to, inside this paint method is where you can actually put drawing commands. Because the paint method is called with a graphics object. So the G that's passed to paint, we can say g.fillRectangle, and it'll fill a rectangle for us.
So you don't only put the graphics object, you put the graphics command.
You put the command inside paint, and you use the G that's passed to paint to know what the graphics object is. Okay, but paint is already a part of a JPanel class, right? So how can we modify it to put our own code in there? Because the default paint behavior basically it sets the color of the background, and it'll add a border if we put in borders and stuff like that. But how are we going to tell it that I also want you to paint a rectangle? So this forces us into another discussion about class extensions. And if you look at the code for our J-frame, it's declared class mainFrame extends J-frame. Okay, so remember, when we extend a class, this new class that we're defining kind of has all the stuff that a J-frame has in this case, plus whatever else we write. And if we write something that's already a part of a J-frame, we overwrite that piece of the J-frame. So this is what we're going to do to write our own paint method. We're going to extend a JPanel, and then we're going to write our own version of paint. And it can be as simple as this. So let's make a new class. And I'm just going to call this my panel. And I'm going to put in this keyword extends, and I'm going to say this extends a JPanel. So right now, my panel has all the stuff that JPanels have. And I got to import JPanel because it doesn't know what it is. Okay, so there's a JPanel. And over here, when I do this content pane, which is a JPanel, I'm going to change that and make this a my panel. And when I construct it, I'm going to say content pane equals new my panel. So if I run this right now, nothing particularly exciting happens. Right, I've got my window, it looks as usual. But let's get something up before we quit for today. So we have to import graphics, of course. So I'm writing one method in my class called paint. It's void, it takes a graphics object, and I'm just calling fill rectangle. And if I run this, I got a rectangle in my panel. But there's a lot going on to put this rectangle up, right? What's happening is my main class, my main frame, it creates a frame, okay? It constructs a my panel. It sets the border and the layout. It adds it to the J frame. And my panel is a J panel, but with my own paint method. And the paint method gets called by the system when it wants to display this panel. So if it's a J panel, when it's trying to draw it, right, because it's visible over here, when it's trying to draw it, it'll call JPanel's paint method. In this case, since it's trying to draw my panel, it'll call my panel's paint method, which I've written myself.
So it's like a two-string?
So it's kind of like a two-string. It's the same thing we were using two-string for. We were making our own version of a method that was already available in object, which we extended. So it's the same setup. We can put a little print message in here and just see where paint is called. And it called paint 4 times, right? And if I move this around, that's fine. But if I take it off screen and bring it back, that's fine. If I resize it, it calls paint, right? And we don't get to call paint directly. The system is calling paint. Whenever it decides that it needs to redraw this frame for some reason or another, it will go ahead and call paint. So if we occlude it and then we expose it, it'll call paint, and so on and so forth.
So how do we get the system to call paint?
Call repaint.
Okay.
So we'll start with that tomorrow.